Okay, this is going to be an overview for lab number 3. So I'm going to write it down here, lab number 3. On this lab, I'm going to go ahead and build a layer 2, layer 3 fabric using the Dell VLT technology. And if you watch my previous videos, especially lab number 2, you're going to see that we are using that technology to provide a redundant pair of switches, multi-layer switches, right, running layer 2 and layer 3 protocols for giving redundancy to downstream devices. So let's say that you have, for example, in this particular scenario, you have VLT spine 1, and then you have the VLT spine 2. Once you create the VLT domain, these two switches are going to look like a single switch. For downstream devices, it can be a directly connected server, or, for example, let's move on to this drawing over here. So this is switch 1, which is the one I drew over here, spine 1. This is spine 2. That's what I drew over here. So let's call it VLT and VLT. So those are going to be the switches, right, that are going to provide that layer 2, layer 3 boundary that will allow us to do the north-south traffic. Okay, so on the layer 2 section of this boundary is where we're going to have our servers that need layer 2 adjacency. Another thing that requires layer 2 adjacency in this case can be, for example, a rack, and this rack is going to have a couple of switches. If you look at lab number 2, that's going to make sense. You have a couple of switches here, and these couple of switches normally are called top of rack. They can be middle of rack, end of the row. In this case, let's call them top of rack switches. And these top of rack switches, each leaf is going to connect to spine 1 and spine 2, and then leaf number 2 is going to connect to spine 1 and spine 2, and then we're going to create a port channel to aggregate the bandwidth and have all the links active going to this pair of switches, providing not only high availability but also the full bandwidth for all those 4 links, so there is no block ports. So all the links are forwarding traffic, right? So let's see what else. So if we go back to this drawing over here, let's go ahead and draw the demarcation line, which is going to be about right here, just to give you an idea. And on this boundary, let's call it boundary, is what I drew already over here. So basically you're going to have your layer 3 going from this boundary up, and from this boundary down you're going to have your layer 2 adjacency. And on the layer 3 section of this topology, we're going to, well, actually I'm going to be configuring a dynamic routing protocol such as open short path first that will allow us to create a dynamic routing topology. Now the process for OSPF is going to be OSPF process 100, and the area is going to be area 0. So that's what the lab is going to be about. It's going to be able to set up these 2 spines, right? So that way, let's say that you have rack 1 Let's say that you have rack 2, rack 3, rack 4, rack 5, and on each rack you're going to have a couple of switches for top of rack, just like I drew over here on this logical drawing. I'm going to draw it over here because you need to see the context within the lab. So now you're going to have another Tor top of rack here, another couple of switches, 25 gig, 48 ports each. Let's call it Tor again. Let's do rack 1, let's do rack 2, let's do rack 3, let's do rack 4, and let's do rack 5. Just to give you an idea, let's keep on building this network. I just didn't know how to approach this conversation, because in order for me to show you just the lab and the configuration, that doesn't, I feel it doesn't have any meat. So just by giving you some context, some real scenarios, maybe you can see the purpose of lab number 3. So now that we have five racks, each one with 2 switches of 48 ports of 25 gig, each leaf is going to have 4 ports of 100, just to give you an idea. Let's say that we are using 100 gigabit switches for spine 1 and spine 2. Let's say that we connect one 100 gigabit link to spine 1, another 100 gigabit link to spine 2, right? And then let's say that we connect from leaf 2 to spine 1 and leaf 2 to spine 2. So now we can create a port channel of 400 gig going to these 100 gigabit switches, right? And that is the idea. So another term that you need to be familiar with is that if you think about it, this layer 3 basically is going to give us the core, right? The core switches for layer 3, and it's going to be a collapsed core, because over here these same switches are going to giving us the aggregation on layer 2, right? And we are aggregating rack 1 through rack 5. That's what we're doing. We're aggregating. So basically in the 3-tier topology, these are going to be the access switches, right? So you have, let's highlight, let's see, you have the core, aggregation, and access, and basically what you have on these switches, you have collapsed cores. Okay, basically you have the layer 3 and the layer 2 function, and over here on the rack you have the access. But for this server right here, it changes, because this is a directly connected server. Well, I'm using a server that is mimicking, I'm using a switch that is mimicking a server. And in this particular occasion, this server is connecting directly to the VLT leaves, I'm sorry, to the VLT spines. And because it's connecting to the VLT spines, that you're going to have the core, you're going to have the aggregation, and layer 2 and layer 3, and also these switches are going to be access, so that way you see that on these multifunction switches you can not only have other switches, right, downstream as access, but you can also connect servers directly to this. The only problem with connecting this server directly to these two spine 1 and spine 2 is that it's going to occupy 2 ports that you can use to aggregate more racks. Now if this were to be a storage device, I wouldn't feel bad at all, because if you have a storage device, now you have a storage area network, that an IP SAN, for example, and that will make a lot of sense, right? To be able to have these servers, right, or with virtual machines perhaps, and then using this virtual IP SAN. So I think that will be a beautiful scenario, instead of just me having a server here. But that's the idea of this conversation, right? So each of the switches are gonna have VLAN 200, switch 1 and switch 2, for example, with their own IP address, 252 on spine 1, 253 for spine 2, and the virtual IP address for the virtual redundancy routing protocol is going to be 254, and I explained that on the previous video. For lab 2, it's showing here the commands needed to create the VLT domain 1. This is the virtual MAC address that I manually created. The idea for you to create or to choose a VLT MAC address for this, I will say the virtual routing. I'm sorry, for this VLT domain is because whenever there is a failure in one of the switches, or if they have to share information, it is the topology converge faster if you have a manual MAC address, and because if you don't add a manual MAC address, then it's going to take a little bit longer to converge just in case there is a failure. And this is the backup destination, which is the management interface 12, which it belongs to this guy over here, switch spine 2. And this let me see what else. Okay, so that's gonna be one. Okay, and 11, this is gonna be the management interface from spine 1. So basically they fail over to each other using those IP addresses. Now, because we are using the OSPF routing protocol, we're gonna create some loopback interfaces, loopback 0, for example. And for spine 1, we're going to be using the IP address of 1111. And then over here for spine 2, we're going to use the loopback 0 interface 1112, just to keep it simple. And it's going to be part of the OSPF process 100, and the area is 0. And just like I explained over here, and the same thing over here, whenever you go to the these routers over here, they're switches, but they're multi-layer switches, so they can mimic a router. So over here on this upstream router, we're going to be using loopback 0 with the address 1113/32, and it's going to be part of the OSPF process 100, area 0. The same over here for switch number 4 or router number 4, loopback 0, address 1114/32, part of the OSPF process 100, area 0. So you get the idea. I'm gonna stop here. The next lab is gonna be just a tour of looking at the switch configurations of switch 1, spine 1, switch 2, spine 2. Those are the two that are gonna give you that layer 2, layer 3 boundary, layer 2 for the layer 2 adjacency needed for servers, storage, and many other devices, and the layer 3 or core going up to upstream devices. On this particular, another thing you can do, you can install firewalls right upstream from the spine 1 and spine 2. That is one way to do it. There is other ways to do it depending on how much traffic you have. So these firewalls can be northbound into that layer 3 environment, using OSPF. Perhaps you have over here another switch, because a lot of the firewalls don't have enough Ethernet ports. So that way perhaps you can create a DMZ and add another switch over here. And maybe you can have some web servers that are facing the public internet, right? Or maybe some other devices that need to be on a demilitarized zone, for example. So this is a pretty good lab that is going to serve, I guess, perhaps 80% of the customers that have a data center. Of course, if you have a larger data center, there is other technologies that can be implemented, especially if you have thousands of physical servers. And I'm going to stop right here. Leave your comments. Tell me what you think. And I'm going to get ready for lab 3, going over the configs, and some verification as well.